Okay, in this question we have an inductor connected to a DC supply and then to an AC supply here, and the idea is to work out what the inductance of the coil is. So, as you may remember, the first thing we do is with a DC supply we can calculate the resistance R using Ohm's law. Then once we've got that, we can plug it to an AC supply, find the total impedance of the coil with a current of 25 amps flowing through it, and then using the idea of the impedance or the reactance due to the inductor and the resistance acting at right angles to each other, we can use Pythagoras and the tangent function to find the impedance XL. So have a go at this, pause the video at this point, try it, and then I'll go through the solution. So the first step, using Ohm's law, voltage is 20 divided by the current, it's 5, gives us a resistance of 4 ohms. So now we plug it into our AC supply. We know that this value here, resistance, is 4, so that's 4. Now, again we could use Ohm's law to work out the total impedance of the circuit. So T, that's again equals the voltage, which is 200, over the current, which is 25. And so that equals 25 over 200 is 8. So we've got a current of, a resistance of 8 ohms for the total impedance. So we know that this value here, total impedance, is 8. So now we can plug these into this formula and work out, by rearranging Pythagoras, we can work out what XL is, because we know that this is 4 and this is 8. So see if you can carry on with that. Once we know what this value here is for the impedance, or for XL rather, this is this value here, so we can use the tangent there to get the phase angle if we're asked it, which in this case we're not. So, it's just a case of rearranging Pythagoras. So, total impedance squared equals R squared plus XL squared, that's Pythagoras. I'm after XL, so subtract R squared and square root. We've got XL equals the square root of the total impedance squared minus the resistance squared. So now we just plug these into the calculator. So that will be 8 squared minus 4. And then putting those into the calculator, we get the value for the impedance. So this turns out to be 6.9 ohms. And that's the impedance of the inductor. If we look back at the original question, we're also asked to find the inductance of the coil. So let's work that out. We know the formula from the data sheet. So the formula is given to us for the inductance of the coil down at the bottom there. So we have XL equals 2 pi FL. We know the frequency is 50 Hertz, so that equals XL over 2 pi F, and we work out what that is again on the calculator. And it turns out to be 0.0219 henries or 21.9 millihenries.